Hey guys, it's Miss Miklos, and today we are starting Chapter 8, and our first lecture is just going to be a general overview of the whole chapter. So specifically today we're talking about sequences, summation, and factorials. So today's going to be pretty general, but the one thing that we're really going to take a close look at is the way that we should write our notation. So the first thing I want to do is actually define what a sequence is. An infinite sequence is a function whose domain is the set of positive integers. Okay, and that sounds a little bit confusing, but an infinite sequence, we know it means that the domain continues forever and ever. Okay, and the function values, we would say it's a sub 1, a sub 2, a sub 3, a sub 4, all the way up to a sub n, and then it would go past that. Okay, those are the terms of the sequence. If the domain of a function consists of just the first n positive integers only, then we call it finite because it actually stops somewhere. So just to further explain the way that we name terms, a sub n is we call the nth term, where n is a non-negative integer. Thus, a sub 1 is term 1, a sub 2 is term 2, and so forth. So the first thing we're going to do here is we're just going to go ahead and write the terms of a sequence. So in this case, it says write the first 4 terms of each sequence. So for part A, I'm going to start by finding a sub 1, and that means that I'm substituting 1 in for n. I'm also going to substitute 2 in for n, 3 in for n, 4 in for n, hopefully you guys are getting the hang of it here, and 5 in for n. So I end up getting 3 minus 2, which is 1, 6 minus 2, which is 4, 9 minus 2, which is 7, 12 minus 2, which is 10, 15 minus 2, which is 13. And I went one step too far. Apparently I cannot read my own directions because it says we only needed the first 4 terms. So I don't need to worry about this one, but hey, you got your money's worth there. So we would say our first 4 terms are 1, 4, 7, and 10. Okay, we will eventually learn that this is actually what we call an arithmetic sequence. And we'll talk more about that actually in our next lecture, but today we really could care less about that. We don't care what type of sequence it is. We're really just focusing on can we find those terms. Okay, for B, a sub 1 would be 3 plus the quantity negative 1 to the first power. A sub 2 would be 3 plus negative 1 to the second power. A sub 3 would be 3 plus negative 1 to the third power. A sub 4 would be 3 plus negative 1 to the fourth power. Okay, so if I'm working this, I know when I take a negative 1 to an odd power, it's going to be negative 1. When I take negative 1 to an even power, it's going to be positive 1. So 3 plus negative 1 is 2. 3 plus 1 is 4. 3 plus negative 1 is 2. 3 plus 1 is 4. So this time our sequence would be 2, 4, 2, 4. And this is a type of sequence. It's not arithmetic or geometric. We would just say that this is a sequence. So a lot of your homework tonight is going to be like this. Okay, it's just understanding what a sequence looks like. In fact, there's another way that we can do this as well using our calculator. So in order to view the terms of a sequence on your graphing calculator, you can change your modes to dot and sequence. Then enter the sequence formula in y equals and go to the table to see the terms of the sequence. And at the very end of the video today, I'll go ahead and kind of walk us through that. Okay, so one more. It tells us to both do it algebraically and using our graphing calculator. Right now I'm just going to do it algebraically. Then, as I said earlier, we'll go back and look at the graphing calculator later. So this time, it tells us to find the first 5 terms. So I'm going to start by finding the first term. I have negative 1 to the first power, which is negative 1, over 2 minus 1, which is 1, so I get negative 1. A sub 2 would be negative 1 squared over 2 times 2 minus 1. So I get positive 1 over 3. A sub 3 equals negative 1 cubed over 2 times 3 minus 1. So I get negative 1 over 5. Now, at this point, we can continue to go ahead and find all the numbers like this. However, I'm actually seeing a little bit of a pattern here. I'm noticing, first of all, that it's alternating signs, negative, positive, negative. And it looks like we always have a 1 in the numerator, and the denominators are odd numbers. So 1, 3, 5. I'm thinking my next number is 1/7, and then negative 1/9. If you guys ever get to a point where you think you have the pattern figured out, feel free to skip some steps. And I just want to verify that a sub 4 really is 1/7 just to show us. So negative 1 to the 4th power over 2 times 4 minus 1. I would get 1 over 8 minus 1 is 7. A sub 5, negative 1 to the 5th power over 2 times 5 minus 1. I would get negative 1 over 9. Okay, so that's how we find the terms of a sequence. The next thing we're going to talk about is finding the sum. And I know some of you guys have done this previously, but the new material is our notation here. Okay, so this is the letter sigma. So this is a Greek letter, and sigma means that we are summing. So we call this summation notation. You'll also see this called sigma notation. So the sum of the first n terms of a sequence is represented by the sum. Our function is a sub I, where I equals negative 1 to n. I is called the index of summation. This could be any variable. We'll often see I there, but if we see n or j or something, we don't need to worry. The important part is this number here. That's our lowest number of the lower limit of summation. This is the very first value we're finding, so we need to find a sub 1. This top number is what we call the upper limit of summation, and that is the biggest number we're finding. So in this case, it's saying we're finding the first term to the nth term, and then since we're summing them, we would go ahead and add them all together. Okay, so let's actually see this in action here. So number 4. Okay, this is telling me that I need to find from the first term to the 5th term. So I'm going to go ahead and write a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. Okay, that's what it's asking me to do. Now we need to find each of those terms separately, which is what we just practiced in those first few problems. So a sub 1 means that I'm replacing I with 1. So instead of 3i, I'm going to think of this as 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. So I get 3 plus 6 plus 9 plus 12 plus 15, which gives us 45. And yes, we will learn some shortcuts in the next few lectures, some formulas that we will memorize to help us find this in an easier way. But I really want us to get used to this notation and the fact that we can just find these terms and sum them all together. Okay, for B, this time it's telling us we're starting at the 3rd term and going to the 6th term. So I'm going to say a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. The other thing I want to point out here is that we're using the variable k. It doesn't matter what we use. That's totally fine. So my first term is going to be 1 plus 3 squared. My third term is 1 plus 3 squared. My 4th term is 1 plus 4 squared. My 5th term is 1 plus 5 squared. And you got it, my 6th term is 1 plus 6 squared. So I have 10 plus 17 plus 26 plus 37. When I add these all together, I end up getting 90. Now, most of our problems are going to be that level of difficulty. But all of a sudden, if we look at C here, we have something that we've never seen before. Okay, and we're going to talk about this a lot on the next page, but I just want to make a note that this symbol signifies something that we call a factorial. Okay, what a factorial is, it is multiplying all the integers up until that number together. So if we just want to see a practical thing, if I was doing something like 4 factorial, that's telling me to do 4 times 3 times 2 times 1. Okay, 2 factorial would just be 2 times 1. Okay, so that is what a factorial is. There's actually a factorial button on your calculator, and we'll talk about that in a moment. So, for this problem, it's telling me to start with our 0 term. So I'm going to have to do 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus, we're going to 8 here, 1 over 6 factorial plus 1 over 7 factorial plus 1 over 8 factorial. So going through this, something that we will learn, and we'll talk about this, 0 factorial is equal to 1. So I would get 1. 1 factorial, 1 times itself is just 1. 2 factorial is telling me 2 times 1, so I would get 1/2. 3 factorial is 3 times 2 times 1, so I would get 1/6. 4 factorial is all of this, so 6 times 4, because it's going to be 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1, so I would get 120. 6 factorial, we get 720. 7 factorial is 5040. And 8 factorial is a giant value. It is 1 over 40,320. Now, when I add these all together in my calculator, it gives me a decimal value, and it actually will not convert this into a fraction because it is not a rational number. So my answer is going to be 2.718. Okay, so we already saw this, but the definition of a factorial, n factorial is defined as n factorial is 1 times 2 times 3 times 4 times n minus 1 factorial, or I'm sorry, times n minus 1 times n. So we can kind of see these values. And we know that it doesn't matter the order we write it in because multiplication is commutative. The way that we find this button in our calculator is if you press math and go to probability. Okay, and we will find this factorial button, and I'll go through that with you when we go through the calculator stuff. So example 5 says list the first 5 terms of the sequence given by a sub n equals 2 to the nth power divided by n factorial starting with n equals 0. So I need to start here. Let's zoom in here. I need to start finding a sub 0. So I would have 2 to the 0 over 0 factorial. I know anything to the 0 power is 1. 0 factorial is 1. So our first term is 0, or is 1. The 0th term is 1. Okay, a sub 1. 2 to the first power over 1 factorial would give me 2. A sub 2. 2 squared over 2 factorial would give me 4 over 2 times 1, so 4 over 2 is 2. A sub 3. 2 cubed over 3 factorial gives me 8 over 6, which is 4/3. A sub 4 would give me 2 to the 4th over 4 factorial. Okay, that would give me 16 over 24, which would be 2/3. So it looks like this sequence would be 1, 2, 2, 4/3, 2, thirds. The last thing we're going to do here is example 6, and it's evaluating the following factorial expressions. And the reason why I want to go through this, obviously we can put this in our calculator, but often we can see some shortcuts. So I'm going to write everything out here, but hopefully we can kind of see where we could skip some steps. I know 8 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Over 2 factorial is 1 times 2. 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. Now, the thing that I notice with 6 factorial, I can cancel these out with 1 through 6 on the top. So, if we kind of see this, I could think of 8 factorial as just 7 times 8. If I just had this, I would think of 8 factorial as 3, 4, 5, 6, 7, 8. Okay, so that's something we can start to simplify in our heads. So if I multiply straight across, I get 56 divided by 2, which is 28. Okay, our next one, 2 factorial is 1 times 2. 6 factorial, 1 times 2 times 3 times 4 times 5 times 6. In our denominator, 3 factorial is 1 times 2 times 3, and 5 factorial is 1 times 2 times 3 times 4 times 5. So I'm noticing those two and these two cancel out. 1 through 5 and 1 through 5 cancel out, so I'm left with 6 over 3, which is 2. Now, obviously we could do this using our calculator as well, but I'm just showing us that we could think of this by hand. Our last problem is probably the toughest one because we cannot use a calculator. We just need to think through this. So in factorial is 1 times 2 times 3 times ... times n minus 1 times n. Okay, so this is what can be slightly tricky. We have this section in here where I'm not writing out all the numbers, but we know that they exist there. We know n factorial means I'm going from 1 to n, so the number before n is going to be 1 less than it. So that's how I got n minus 1. For n minus 1 factorial, it would be 1 times 2 times 3 times ... Okay, if n minus 1 is the last one, I know n minus 2 would be the one before that. And something that I notice here is these cancel out with all of these. Even though I did not have n minus 2 written, it's right here. That's just 2 minus that one. So I am just left with n. And if we think about it, if I had something like 8 factorial over 7 factorial, that's telling me my answer is just going to be 8. 120 factorial over 119 factorial would be 120. Okay, so this can actually save us a lot of time, but we will have some problems possibly on the quiz, but definitely on your suggested problems that are going to look like this. Okay, so now get out your graphing calculator and I'm going to show you guys how to use it for this lesson. Okay, so I just really quickly want to show you how we can also do this in our graphing calculator. So the first thing we're going to do is go to our mode. And your mode probably looks something like mine does right now. And I'm going to go ahead and change, instead of function, I'm going to make it sequence. So I'm going to press enter on sequence. And I'm also going to make it, instead of thick, I'm going to make it dot. So what this is doing, it's not connecting the points, it's keeping them all separate. Okay, so now I'm going to press y equals. And notice it looks really strange, and that's okay. But I'm going to go ahead and type something in. So I'm going to go ahead and go through example number 3. So I'm going to do -1 to, and I just pressed that X, and notice all of a sudden n came up, and that's okay. Divided by, then I'm going to put in parentheses, 2n minus 1. And if I go ahead and go to our table, so I'm pressing second graph, This brings me to my table. Notice it tells me -1, 1/3, -1/5, and so forth. And we found that our answers were -1, 1/3, -1/5, 1/7, 1/9. And as I continue down here, that's what all these values are equal to. Okay, so that's how I go ahead and do this in my calculator. If I want to change back, okay, I want my mode to be in function and thick. So remember, if I want to look at sequences, I'm going to do sequence and then choose dot. Okay, second thing that we talked about was our factorial. So if I want to do 8 factorial, obviously I can type in 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. But that takes a while. So the other thing we can do, if I press 8, if I press the math button, okay, if you look over here, we have something called probability. So I'm going to move over to the probability menu. And we're actually going to be using a lot of these, actually probability or permutation and combination we're going to use later this chapter. But number 4 here is our factorial, and it would go ahead and give me my answer. So math, move over to probability, and choose option number 4. So that's it for this lecture. Hopefully this is a great intro to what's going to be a fun and slightly different chapter.